okay, is given by the function. I'm looking at it again. Negative 5a squared minus 3n squared plus 48a minus 4n. So far, so good. Plus 2an plus 290. A is the amount spent on advertising in millions. And n is the number of items sold. So n items and a dollars in millions. Okay. And the items are in thousands. Okay. I took notes on that. Find the max value of P and the values of A and N, at which it occurs. Perfect. Okay. Good. First step. So in this case, instead of writing fx and fy, we will write PA and Pn. So this is the function, which is our f of xy. We used to write fx, but now we have to write PA and Pn. We're differentiating with respect to A.
Negative 10.
A, good. With respect to A.
0.
With respect to A, perfect.
48.
Good. With respect to A.
0 again.
With respect to A.
2m. Or 2n, sorry.
Yes. And this is 0, goodbye. Perfect. Now with respect to N. With respect to N. With respect to N.
Negative 6n.
Perfect. With respect to N. With respect to N.
0.
Yes. With respect to N.
Negative 4.
Yes. With respect to N.
2a.
That's it. Done. In step number 2. Good. I will move the 48 to the other side. I will move the negative 4 to the other side, and I will present A under A, N under N, equal symbol under equal symbol, free terms under free terms. I will rearrange the system. It's not ready. So I'll keep A first. Negative 10A plus 2N equals negative 48. We are moving one term from one side to the other. We change its sign. So now, in correct order, 2A minus 6N, it was negative 4. I'm moving into the other side. It becomes positive 4. And now we have to decide, yes, we can simplify both by 2. We can divide both by 2. Also, we can decide to eliminate one of the variables. Which of the variables you would like to eliminate? If you want to eliminate, yes, go ahead.
Can we eliminate a?
Yes. So if we eliminate A, we have to multiply the second equation by
2.
2 times 2 will not be negative 10.
Oh.
Right?
5.
Good. So we want to multiply by 5 because 2A times 5 will be positive 10, and then we can eliminate A. Perfect. I'm going to copy it again. Negative 10A plus 2N equals negative 48 plus 10A minus 30N equals 20. 5 times 2, 5 times negative 6, and 5 times 4. Now this is gone because they are the same with opposite signs. So this is negative 28N, and this is negative 28. Beautiful. So then N equals
1.
Perfect. And yes, it's one time. It's in thousands, so it will be 1,000. But we have to use n equals 1. Perfect. At this point, we go back anywhere you want, preferably in the organized one, correctly organized one, and put n anywhere you want, either here or here. Let's put in the second equation. 2a minus 6 equals 4, or 2a equals 10, because we're adding 6. So then a equals
5.
perfect. Careful how we present the ordered pair. It has to be in the exact order as it is presented in the function. A, n. That's the ordered pair. So what is the ordered pair, which is the solution of the system?
5, 1.
5, 1. 5, 1,000,001,000. Good. So now in step 3, what do we determine in step 3?
FXX, FYY.
Perfect. Perfect. PAA, PNN, and PAN. Awesome. So we are here. We are differentiating this with respect to A. What do I get?
-10.
That's it. That's it. Awesome. We are differentiating this again with respect to N.
-6.
That's it. Now we are differentiating this PAN with respect to N. This with respect to N, this with respect to N, this with respect to 2 indeed. Lovely. I don't even need to plug in anything. But this is what I'm testing, right? So in step 4, we have D equals FXX times FYY minus FXY squared. So since this is 60 minus 4, I don't care what the number is. The result is positive. And PAA at 5, 1 is negative. What do we conclude from here about 5, 1? What does it give?
It's a max.
Because the PAA is negative. Yes, a relative max. What is the relative max? I have no clue. I have to plug in 5 here and 1 here, and I'll know. So P of 5, 1 is the relative max, but I have to calculate it. Okay, so I have -5 times 25 minus 3 times 1 squared plus 48 times A, which is 5, minus 4 times 1, which is 4, plus 2 times 5 is 10 times 1, so 10, and plus 290. I don't know what that is. We'll see in a moment. So negative 125, these two, and then minus 3, and then plus 48 times 5, and minus 4 and plus 10. I could have written plus 6 and plus 290. So the answer is 408. So 408, let's see again the problem. Find the maximum value of P. So P is in millions of dollars. So millions. Million. Okay. And the values of A. A is 5 million and N is 1,000 where it occurred. So I'll say 5 million. So A equals 5 million and N equals 1,000 units because it says in thousands. There is one thing I wanted to show you because I did not, and it is on page, going back. Okay, on page 562, one thing here on 562. This is just for your information so you know what this is. So whenever we are looking at a function of two variables, x is independent and y is independent. So this is the third variable, which is the function, right? X, so the function depends on x and y. When we graph this, it looks like it's a surface, right? Like a piece of a, in this case, just imagine you cut a football and you just take a piece of it. So this is what this is. Now, when we want to differentiate, when we differentiate with respect to y or with respect to x, it says we are keeping x fixed. So what does it mean? If we keep x fixed, this is like a wall. Imagine that we are cutting this piece of the football right somewhere, and it creates this cut. So this wall creates this cut, this cut in the piece that we removed from a football. And inside this wall, because it's fixed, in other words, x is constant, we are looking at how fast is the function changing on this green curve. So this is what we are trying to do. We keep x fixed, and we want to see how fast is, as you see, we are determining the slope of the tangent line on this cut. And the cut is created by the wall, by the vertical wall when x is fixed. Of course, we can do the same thing when y is fixed. When y is fixed, we cut this piece of the ball, and by this wall, it creates this cut inside. It's like a slice of a bread. And then we are really interested to see how fast is the function changing on this curve. So you know what how functions of two variables look like. And the other one that I wanted to quickly show you is on page 570. These are awesome graphs that I would be able to create, but not as good. Okay, here it is. So this is a surface. And up here is the relative maximum that we just determined based on fx and fy set equal to 0. We determine this point, right? We determine the a comma b like we just had, 5 comma 1. And then we determine whether it's a maximum or it's a minimum. So these are surfaces in 3 dimensions. Here's the function of x and y. Okay? So it's possible at such a surface to have a minimum and 2 relative max. And we can also consider that that is the maximum because there are 2, so this is the biggest. So this is all based. Now, this is considered, it's called a saddle point. This is like a saddle on a horse. And this is what happens when D is 0. It's a saddle point. There is no max or min there. Okay? That's a saddle point. There is no max and no min. Why? Because there are higher values than it, and there are lower values than it. So this is no point of interest in the sense of max min. Okay, and now the final section that I wanted to talk about, as I promised only with a calculator, is the last section. And you can say, why is this last section here, 6.4? So 6.4 has several different applications, but we are going to look only at the linear regression. line. And I'm just going to show you what it is, and then we'll calculate it with a calculator. Okay. So let's suppose I have 15 students in my class, and I measure 2 variables. Of course, that's why this section is here in chapter 6, but because I measure 2 variables on you. Let's say I measure your height and blood pressure. I meant blood pressure. Okay, so, and when I measure both for each and every one of you, well, let's say, I'm just making up numbers. Let's say I determine height, I don't know, 56 and 100, I'm just making numbers up. 70 and 120, let's say 61 and 100 and or 90, and so on and so forth. Now, this is my x and this is my y. I'm going to plot this, and let's say it's this point, x comma y. I'm going to plot this, and let's say it's this point. I'm going to plot this, and let's say it's this or this and this, and then I put in all the 15 points. And I have all of them there. And I say now, is there a way, since it kind of appears to be linear, is there the line of best fit? Line of best fit that has the least amount of error. There is no line that goes through all these points. It's not possible. But this line is not the best fit because the errors are so big. This is the best line because the errors, the distances between the actual values and the line, are the smallest. So that's why we say the least amount of error. And that line is called the linear regression line. Why is the linear regression discussed in this chapter? Number one, because it deals with 2 variables. Number 2, why at all? Okay, forget it. What is calculus here? What are you talking about? Well, whenever we talk about max min, we want to find minimum. This is the first derivative, right? Derivative. So if we want to determine the line that has the least amount of error, immediately our thoughts go to the minimum. And once we talk about minimum, we talk about derivatives. So the way the line is calculated comes from finding the minimum of the error. The calculations are elaborate. I'm just going to show them to you. We are not going to go through. So let me see which page I have to show you those. Oh, they don't even present them. They don't show anything. Oh, okay, so I have nothing to show you. So let me just show you with a graphing calculator. I thought a table was or something with all the step-by-step procedures, but no, the book doesn't show that. Fine. So now let's choose. Find the regression line for each data set, xy, xy, xy. We will not talk about the exponential regression, only about linear regression. Hourly wage. The minimum hourly wage in California has grown over the years, as shown in the following table. Find the data, for the data in the table, find the regression line. So let's do this one. Is that okay? Yes?
Yes.
Okay.
Yeah.
Yes.
So I'm going to have to copy this because when I type it in the graphing calculator, so I have 0, 2, 3, 4, and 5. And this is 9, 10, 10, 50, 11, and 12. Perfect. Okay. So we go to the graphing calculator. We go to stats. Stats. we edit. So please clear those lists in case you have anything in there. So highlight list L1, clear, enter. Highlight list L2, clear, enter. Go back, and the correct order, 0, enter, 2, 3, no, I didn't mean that. I meant 3 now. 3, 4, and 5. Good. And corresponding, do not change the order. They have to be the correct order. The two ordered pairs come from the same person if you want. 11 and 12. So now careful. If I want to graph this, which I will, x goes from 0 to 5, and y, if you want, from 0 to 15. Okay? We're not going to graph it just yet. Let's go back to stats. Calculations. We're going to use linear regression. This symbol here, number 4. Careful, list X is in list L1, second and 1. Make sure it says list L1. List L2 is for Y. Store the linear regression equation. Yes, I want it stored. So in order to store it, so back here, okay, I was on number 4, list L1, list L2. So here I want with variables, Y variable, function, Y1. And now calculate. And it's going to give us Y equals the slope times X plus the y-intercept. Press enter. So we have Y equals the slope. 4 digits is good enough. 5743 times X plus 8.8919. Disregard the correlation coefficient and the coefficient of determination. We discussed this in statistics. So now I want to choose the viewing window. I want 0 to let's say 10. That's good enough. With a scale of 2, that's good enough. And anywhere from 0 to 15 with a scale of 3. When I click enter, I should see, maybe not, it will not show me the points. I'll show you how to show the points. It will show us the line. Here it is. Now I want to see the points. I have to go to second and stat plot and activate plot 1 and keep it as the first one. Let's say you can choose different colors, you can choose different symbols. This symbol is good enough for me, and this is the symbol for the scatter plot, this one. So now when I click graph again, I will see all the points that I entered, including the linear regression line. And you can see it's the line of best fit. This line is the only one that has the smallest amount of error. So now the question, and I'll stop, promise. It's asking, use the regression line to predict the minimum hourly wage in 2022. So this is from 2014. So what is X that I have to plug in? Well, I have to plug in 8. So I'll go back to the graph. I plug in 8. And this is the minimum hourly wage, assuming the trend was continuing, $15.49. $13.49. And finally, and this is all based on calculus, although we don't see it, it's all done in the background in the calculator. By 2024, the minimum hourly wage will be this. Is this estimate? So the problem with estimating outside of the range, so if I go too far out of this range of the study of the data that was studied, it may not be valid unless I say, oh, I think this trend continues. Sorry for keeping, I think I did keep you over 1 minute. I apologize, but I'll give it back to you for the test. So sorry about that. Yes, I did, 2 minutes. Sorry about that. So that's the end of the course, and I want to quickly, I know I'm extending my stay, sorry. I wanted to ask you if you want to move the test to Wednesday. And on Monday, we're going to review for test 3, but also review for the final. We'll go back and look again a little bit at test 1 and test 2. Will that work for everyone?
Yes.